Hello, my pre-calculus class. Welcome to our final ed puzzle video for this semester, and especially with me, Mr. Nguyen. It was fun having you guys around, and it was fun making videos with you guys, but let's move on to our final ed puzzle video, which is the sum and difference formula. As you can see, I wrote down the 6 sum and difference formula for you. As you can see, as number 1 is sine of A plus B equals sine A cos B plus cos A sine B. I know this is something you did over the break, but just in case you don't remember, you can write all these down right now if you pause the video. Otherwise, let's continue to our example. So now you're wondering, why are we trying to use our sum and difference formula right now? So you can see in example 1, it says find the exact value. And we have sine of 5 pi over 12, which is in radians. And then you're like, so why do we need the sum and difference formula? Well, if you look into the unit circle, there is no 5 pi over 12. And unless we use a calculator, there's no way to actually solve this. But using this sum and difference formula, we can solve using radians or degrees that we don't have within the unit circle, as I'll show you right here. So we can do, instead of 5 pi over 12, we could split them up into 2 terms, which is adding. So I would add sine of 3 pi over 12 plus 2 pi over 12. Once you do it, if you add this back together, you'll get that. And then let's simplify that even further. So now we get sine of, so when you simplify that, you get pi over 4. Pi over 4 plus pi over 6. Now let's continue. Now you're like, okay, what do we do from there, Mr. Nguyen? Now we can do the sum and difference formula. So I'm going to use my sine of A plus B. So we have sine of A, which is A is our pi over 4. That's what we replace A with. And then we have cos of B, which is right here, which is pi over 6. Now we add it. And now we do cos of A, which is pi over 4. And then we do sine of B, which is pi over 6. Which now you see how this formula comes in handy. Sine of pi over 4 is, in fact, in our unit circle. If you remember, it is square root of 2 over 2. Cos of pi over 6 is radical 3 over 2. And then we go plus. Now we do cos of pi over 4, which is also radical 2 over 2. And then sine of pi over 6 is 1/2. Now we just evaluate them. And then we get radical 6 over 4 plus radical 2 over 4, which now they have common denominator. We could just add them together to get radical 6 plus radical 2 over 4. And that is our answer. Now you can see how the sum and difference formula helps us to achieve something that we couldn't achieve without a calculator. So let's continue on to example B, which is cosine of pi over 12. And we're going to do the same thing. I want to split them up again because this can't be solved without using a calculator for now. But then we're going to find values that we can solve using the unit circle, or our knowledge of the unit circle. Alright, you could have used this, or you could have used something else like 3 pi over 12 minus 2 pi over 12, but we'll just stick with this one, okay? So, from there, we get, when we simplify, we get cosine of pi over 3 minus pi over 4. And then we use the sum and difference formula for cosine. If you remember, it's cos A times cos B plus, because of the operation is minus here, sine A times sine B. So let's do that. So we have cos of A, which is pi over 3, times cos of B, which is pi over 4, plus sine of pi over 3 times sine of pi over 4. Now that's a little easier to do with our unit circle knowledge. Cosine of pi over 3 is 1/2. Cosine of pi over 4, if you remember, was radical 2 over 2 plus sine of pi over 3 is radical 3 over 2. And then sine of pi over 4 is radical 2 over 2. And then we get radical 2 divided by 4 plus radical 6 divided by 4. Common denominator, we can add them together like last time. Radical 2 plus radical 6 all over 4. And that is our answer. If you find it hard to find what cosine of pi over 3 is, I would say go back to your unit circle and study that, just to make sure that you can find all these values without using a calculator, okay? So now for part C, I know this one has a degree. We didn't go over that, but I want you to do this one on your own to see how you can do that. Just remember to split it up in order to find values that you can use within the unit circle, okay? Once you are done, we will go over this problem and see how you did. Now that you've done this one on your own, let's see how you did. So tan of 105, you know we can't do that without with using the unit circle. So we want to use the sum and difference formula, and we have to find values that we can use that are in fact in the unit circle. So in my mind, I know that tan of 45 degrees plus 60 works. And now we're going to use the sum and difference formula. And we know for this one is tan A plus tan B divided by 1 minus tan A times tan B. So we can do tan A, which is tan of 45, plus tan B, which is tan of 60. Tan of 60. And then we get 1 minus tan of A, which is 45 degrees, and then times tan of B, which is tan 60 degrees. And then we know that if you're using the unit circle, that tan of 45 is 1 plus tan of 60 is radical 3. And then, you know, in the bottom will be 1 minus radical 3 times radical 1, which is radical 3. Now we have to do the conjugate because we don't want the radical in the bottom. If you remember, that's how we cancel it. 1 plus rad 3, 1 plus rad 3. The reason why I'm doing this is to not have the radical in the bottom, if you remember. Once you do that, we should get 1 plus 2 rad 3 plus 3. That's from the top, multiplying or foiling. And then the bottom you get 1 plus rad 3 minus rad 3 minus 3, because rad 3 times rad 3 is rad 3 squared, and you know those cancel, so you're left with minus rad 3 there. You see you have a common or like terms, so you can combine those and that will be 0. Once you do that, we get 2 radical 3 plus 4 over negative 2. And we can simplify it even further because we have a negative 2 in the bottom and we have 2 and 4. So we can divide that, and that would be negative radical 3 minus 2. If you got that, good job. If not, just ask questions for tomorrow so we can help you get to where you need to be. Now lastly, we are going to do example 2, which it says find sine of x plus y, where x or sine of x is 4 over 5 and is in the quadrant in between 0 and pi over 2. And then it also says cosine of y is negative 12 over 13, which is in between pi over 2 and pi. So now that we do that, my suggestion would be to actually, let's just draw the graph first to see what they're talking about. So I know this is 0, pi over 2, and pi, and that's what we're looking for. So let's draw our triangle. And we know sine is y over r. Y is this, right here. This is x, and then the r is the hypotenuse. So we know this is 5, and this is 4. And the reason why I know this is 4 is because our theta is usually right here, opposite over adjacent, or opposite over hypotenuse for sine. Just remember theta is always touching both the x and the y. And same thing for this one. Let's do this one now for cosine. So we know theta should be right here. If it's right there, we know this is negative 12. And then we know that this is 13. And then we could solve for the rest as well. So we know using the Pythagorean theorem, this will be 3. And same thing with this, using Pythagorean theorem, we can find this side, which is 5. And now we can, let's help ourselves out. Sine of x cos y plus cos of x sine y. Just remember that formula. Once you get that, we can just start plugging stuff in. So we know sine of x is, our x value is, sorry about that, is 4 over 5. Because we have right here, sine of x is 4 over 5. And then cos y we do have also, which is right here. They gave it to us already, which is negative 12 over 13 plus, now we're looking for cos of x. Cos of x we can find using our triangle right here. So we know that when we found the x, it was 3. So we know that cos of the sine of, or cos of x will actually be 3 over 5. It's adjacent over hypotenuse. And then I ran out of room, but multiply it again. Sine of y is 5 over 13. And now all you got to do is evaluate. So once you evaluate them, I get negative 48 over 65 plus 15 over 65. We have common denominator, so we can just add them through, and then we get negative 33 over 65. And as you can see, knowing where the quadrant was at for sine of x and cos of y helped us achieve like our values, because we know that sine is positive on quadrant 2 and we know cosine is positive in quadrant 1, and that's how I knew if it's negative or positive as well. At this moment, do you have any questions, comments, or concern? Please state them now. Otherwise, I had a blast with all the Edpuzzle video. I really enjoyed making them for you, and I really hope that you guys succeed second semester as well. Peace.